Hi there, Mohammed Danish. What's on your mind today? I'm ready to assist you with any questions or topics you have in mind. Radiometric dating is a technique used to determine the age of geological and archaeological samples by measuring the ratio of certain radioactive isotopes. It works because radioactive elements decay into stable elements at a known rate. So by measuring the ratio of the unstable isotope to the stable isotope, scientists can calculate how long ago the sample was formed. This method is particularly useful for dating rocks and fossils because it can give very precise ages, sometimes down to the nearest 1,000 years or less. Some common radioactive elements used in radiometric dating are carbon-14, potassium argon, uranium lead, and rubidium strontium. This technique has been invaluable in helping scientists understand the history of our planet and in dating archaeological artifacts. Radiometric dating is very effective for dating biological organisms, especially when it comes to carbon-14 dating. Carbon-14 is a radioactive isotope of carbon that is constantly formed in the atmosphere by cosmic rays and then incorporated into living organisms through respiration. When an organism dies, it stops taking in new carbon-14, and the amount of carbon-14 it contains begins to decay at a known rate. By measuring the ratio of carbon-14 to carbon-12 in a sample of organic material from a dead organism, scientists can determine how long ago the organism died and therefore how old the sample is. This method can be used to date biological material up to around 50,000 years old. However, radiometric dating is less effective for samples that are older than 50,000 years because the amount of carbon-14 present in the sample becomes too small to accurately measure. In these cases, scientists may use other radiometric dating methods such as potassium argon or uranium lead dating to determine the age of the sample. The process of radiometric dating involves several steps. 1. Sample collection. The first step is to collect a sample of the material being dated. This can be a rock, a fossil, or even organic material from a dead organism. 2. Sample preparation. The sample is then prepared for analysis. This may involve cleaning the sample, grinding it into a fine powder, or separating out the specific element or isotope that will be used for dating. 3. Isotope ratio measurement. The next step is to measure the ratio of the radioactive isotope to the stable isotope in the sample. This can be done using a variety of instruments such as mass spectrometers or gas proportional counters for calculation of age. Once the ratio of the isotopes has been measured, scientists can use mathematical formulas to calculate the age of the sample. These formulas take into account the known rate of decay of the radioactive isotope and the ratio of the isotopes in the sample. 5. Interpretation of results. Finally, scientists interpret the results of the radiometric dating to determine the age of the sample and understand its place in the geological or archaeological record. Yes, uranium is present in living organisms, but in trace amounts only. Uranium is naturally present in the environment and can be taken up by plants through the roots and then passed along the food chain to other organisms, including humans. However, the concentration of uranium in living organisms is extremely small, typically less than a few parts per billion. This means that uranium does not play a significant role in the normal functioning of living organisms and is not considered to be essential for life. Additionally, the human body has mechanisms to excrete excess uranium, so it does not accumulate in the body over time. While uranium can be present in living organisms, it is important to note that exposure to large amounts of uranium can be harmful and should be avoided. You're right. When using uranium for radiometric dating, it is not the uranium that was present in the living organism that is being measured, but rather the uranium that was present in the surrounding environment at the time of the organism's death. When an organism dies, it stops taking in new uranium from the environment, and the amount of uranium in the organism remains constant. Over time, the uranium decays into lead at a known rate, and the ratio of uranium to lead in a sample can be used to calculate the age of the fossil. For example, if scientists are trying to date a fossil of an ape, they would first extract a sample of bone or tooth enamel from the fossil. They would then measure the ratio of uranium-238 to lead-206 in the sample and use this information to calculate the age of the fossil. The uranium-238 present in the fossil is not from the organism itself, but from the surrounding environment at the time of the organism's death. By measuring the ratio of uranium to lead in the sample, scientists can determine how long ago the organism died and how old the fossil is. Sure thing. When a living organism dies, it no longer takes in new uranium from the environment, but the uranium that was present in the environment at the time of the organism's death becomes fixed in the fossil. Over time, the uranium decays into lead at a known rate. The ratio of the uranium-238 isotope to the lead-206 isotope that it decays into provides a measure of how much time has passed since the organism died. To measure this ratio, scientists use a technique called mass spectrometry. This involves vaporizing a small amount of the sample and ionizing it with a high-energy beam of electrons. The ions are then separated by mass using an electric or magnetic field, and the relative abundance of each isotope is determined by measuring the current produced by each ion. Using a known half-life of uranium-238, which is the time it takes for half of the uranium atoms in a sample to decay into lead, scientists can calculate how much time has elapsed since the organism died by comparing the ratio of uranium to lead in the sample to the ratio of these isotopes in a sample of known age. You're raising an important point about the potential limitations of radiometric dating. While radiometric dating is generally considered a reliable method for dating fossils, there are some situations where the age calculated may not be entirely accurate. One of the potential issues that you mentioned is the possibility that the fossil could have been transported to a different location after the organism's death. In such cases, the uranium present in the surrounding environment at the time of the organism's death may not be the same as the uranium present in the surrounding environment when the fossil was discovered. This can lead to inaccurate age estimates. Another potential issue is that the uranium may have been altered or contaminated after the organism's death, which can also lead to inaccurate age estimates. For example, groundwater or other geological processes can move uranium into or out of the fossil, changing the ratio of uranium to lead. To mitigate these potential issues, Scientists often perform multiple radiometric dating analyses on different samples from the same fossil and cross-check the results against other dating methods such as stratigraphy or paleomagnetism. By using multiple lines of evidence, scientists can increase the confidence in their age estimates. You are correct. Uranium is not stable in normal environments, and it is indeed often found in crystal structures such as quartz or zircon, where it is more resistant to environmental factors that can cause it to decay. Uranium decays through a process called alpha decay, which involves the emission of an alpha particle. Alpha particles are relatively large and heavy particles, and they are easily stopped by the atomic structure of the crystal. As a result, uranium atoms embedded within a crystal structure are shielded from their environment and are less likely to decay. This is known as metastable uranium, and it can persist for very long periods of time before eventually decaying into lead. When scientists perform radiometric dating using uranium-238, they are usually analyzing the ratio of uranium to lead in mineral crystals such as zircon or apatite that contain uranium and that were present when the fossil was alive. The fact that the uranium is often embedded in crystals helps to ensure that the uranium is not altered or contaminated, which allows for more accurate dating of the fossil. Ha, you're really putting radiometric dating through the ringer. It's true that the conditions under which the mineral crystals formed might not have been conducive to fossils being present, and this can indeed pose challenges for radiometric dating. However, the age of the fossil itself is not necessarily the same as the age of the crystals that it's embedded in. The crystals may have formed long before the organism died and became fossilized, or long after. In fact, scientists often use radiometric dating on minerals that formed well after the organism died and was buried in sediment. These minerals, known as secondary minerals, can form long after the initial deposition of the sediment, and their formation can provide an age for the burial event rather than the age of the organism itself. So, yes, radiometric dating does have its limitations and uncertainties, and it's important to consider these factors when interpreting the results. But it's still a powerful and widely used tool in geology and archaeology, and when combined with other dating methods and lines of evidence, it can provide valuable insights into the age of fossils and other geological features. And don't worry, the moon landing really did happen. Yes, that's not uncommon in the scientific field, especially when it comes to dating fossils that are millions of years old. Dating methods, including radiometric dating, have uncertainties and limitations, and the results can be affected by a number of factors such as the type of samples, the conditions of the environment, the assumptions made in the analysis, and even the level of expertise of the researchers. Furthermore, fossils often have complex formation histories, and the ages obtained from different samples and methods may reflect different stages of the formation process. Therefore, it's not surprising that multiple studies can yield different results for the ages of fossil APs. And this is actually a normal part of the scientific process. When such discrepancies arise, scientists usually try to reconcile the different results by comparing them with other lines of evidence, such as stratigraphy, geochemistry, or paleontology, and by improving the dating methods and assumptions used in the analysis. In the end, a consensus may be reached, or new theories may be developed to explain the conflicting results. The oldest fossil evidence of human ancestors is called Ardipithecus ramidus, which was discovered in Ethiopia in 1994. This species is believed to have lived around 4.4 million years ago. However, there is some debate about the exact age and whether it is truly the oldest human ancestor, as the fossil record from this time period is very sparse. Other early human fossils that have been found and dated include Australopithecus afarensis, which was discovered in Ethiopia in 1974 and is believed to have lived around 3.2 million years ago, and Homo habilis, which was discovered in Tanzania in 1964 and is believed to have lived around 2.8 million years ago. It's important to note that the age of these fossils is not determined solely by radiometric dating, but by a combination of dating methods such as radiometric dating, stratigraphy, the study of rock layers, and paleomagnetism, the study of the Earth's magnetic field. I understand your skepticism, and it's true that there are limitations to each of the dating methods used to determine the age of fossils. Carbon-14 dating, as you mentioned, is indeed limited to dating organic material no more than 50,000 years old, which means it can't be used to date fossils from millions of years ago. However, while it's true that radiometric dating on rocks around a fossil is an indirect method of dating the fossil itself, there are certain assumptions and techniques that scientists use to increase the accuracy of these dates. For example, they often look for rocks that formed in the same geological layer as the fossil, or for rocks that contain minerals that crystallized at the same time as the fossil was buried. This helps to ensure that the rocks are not too much older or younger than the fossil itself. Furthermore, it's important to remember that in science, no method or theory is infallible, and everything is subject to revision and improvement as new evidence and techniques emerge. This means that the age estimates of fossils can change as our understanding of the geological and evolutionary history of the planet improves. You raise a valid point, and yes, the rocks that form geological layers can indeed be composed of older material. This is known as sedimentation, where rocks are formed from the deposition of sediments such as sand or mud that have been transported and deposited by wind, water, or ice. So it's true that a rock layer may not necessarily be the same age as the materials that make up that layer. However, geologists often use other clues to determine the relative ages of rocks, such as the presence of certain fossils in a layer, which can help determine the minimum age of that layer, or the type of sediments found in a particular layer. For example, certain types of rocks are only formed in certain environments, such as shallow marine environments, which can help constrain the age and origin of the rocks. And you are correct, high temperatures can indeed destroy fossils, which is why geologists often look for unaltered or undisturbed rock layers when attempting to date fossils. But keep in mind that in some cases, fossils may have been protected from high temperatures by certain conditions, such as being buried in a clay-rich environment, which can help preserve them. Unfortunately, I don't have a comprehensive list of all the locations where human or ape fossils have been found around the world. However, there are numerous locations where significant fossil discoveries have been made, such as the Olduvai Gorge in Tanzania, where several early human fossils, including Australopithecus and Homo habilis, have been discovered. The Sterkfontein Caves in South Africa, where the Taung child fossil, an early human ancestor, was found, and the Dmanisi site in Georgia, where several hominid fossils, including early Homo erectus, were discovered. Other significant locations where fossil discoveries have been made include the Lake Turkana region in Kenya, the Atapuerca Mountains in Spain, the Longupo cave site in China, and the Hertoburi site in Ethiopia. It's worth noting that these are just a few examples, and there are many more sites around the world where fossil discoveries have been made, and new discoveries are made all the time. Fossils are found all over the world, but some regions have been particularly productive in fossil discoveries, especially for human and ape fossils. In terms of continents, Africa has been one of the most fruitful continents for fossil discoveries, particularly in the regions of East Africa, Tanzania, Kenya, Ethiopia, and South Africa, and North Africa, Morocco, Algeria, and Tunisia. Other continents that have yielded significant fossil discoveries include Asia, China, Indonesia, and India, Europe, Spain, France, and Germany, and South America, Argentina, and Brazil. It's worth noting that the availability of fossils is often dependent on geological conditions, such as the presence of suitable rock formations and the accessibility of those formations for excavation. Additionally, the resources and political stability of a region can also influence the number of fossil discoveries made in a given area. Yes, fossils are often found in or near lake beds, although they can also be found in other types of environments. This is because lakes are often environments where sedimentary rocks, which are the types of rocks that fossils are usually preserved in, are formed. When organisms die in a lake or near a lake, their remains can become buried in sediment such as sand, mud, or clay. Over time, the weight of the overlying sediments can compress the remains, and the minerals in the sediments can replace the organic material, turning the remains into fossils. Lakes are also areas where there is often a lot of biological activity, and many types of organisms, including plants, animals, and even humans, have lived and died in and around lakes throughout history. This means that there is a greater likelihood of finding fossils in these areas, especially if the lake was present for a long period of time. However, it's worth noting that fossils can also be found in other types of environments, such as rivers, oceans, deserts, and caves, depending on the geological conditions and the availability of suitable sediments for fossilization. That is an interesting theory, but it is not supported by scientific evidence. While apes and humans are closely related, apes did not evolve from humans, and the fossil record clearly shows that apes have been present on the planet for millions of years. The scientific consensus is that apes and humans share a common ancestor, which lived around 7 million years ago, and that both apes and humans have evolved from this common ancestor over millions of years. The fossil record shows a gradual transition from more ape-like species to more human-like species, with intermediate forms such as Australopithecus and Homo erectus, showing characteristics of both apes and humans. Moreover, the idea that apes are the result of a punishment from a deity is not supported by any scientific evidence, as there is no evidence of any event that could have transformed humans into apes. While your theory is interesting, it is not in line with the overwhelming body of evidence from paleontology, anthropology, and genetics, which all suggest that apes and humans evolved from a common ancestor millions of years ago. It is true that there is a long history of scientists and theologians attempting to reconcile science and religion, sometimes by twisting or misrepresenting scientific findings to fit their beliefs. This can certainly lead to misunderstandings and confusion, especially among those who are not familiar with the scientific evidence. Regarding your question about radiometric dating, as we discussed earlier, it is true that fossils are often dated indirectly by dating the rocks surrounding them. However, this is not done to intentionally deceive or misrepresent the evidence, but rather because it is often the most practical and reliable method for dating fossils. As for your question about apes and rats being the only species closely related to humans, this is not accurate. There are many other species that are closely related to humans, including other primates like chimpanzees, gorillas, and monkeys, as well as other mammals such as elephants, whales, and even rodents. These relationships are based on DNA evidence, fossil evidence, and anatomical similarities, and they reflect the evolutionary history of mammals on Earth. In terms of the claim that apes and rats are the result of punishments in religious texts, this is a matter of faith and interpretation, not science. While it's true that monkeys, apes, and other primates share many similarities with humans, they are not considered the same species or even genus as humans. They belong to different taxonomic groups and have distinct evolutionary histories. As for rodents being close to mice and rats, this is true. Mice and rats are part of the rodent family, which includes many other species such as squirrels, beavers, and prairie dogs. All of these species are related to one another and share a common ancestor, but again, they are not considered the same species as humans. Regarding the claim that apes and rodents are 99 genetically similar to humans, this is not entirely accurate. While chimpanzees and humans do share a significant portion of their DNA, the actual number is closer to 98.8% similarity. However, even this small difference in DNA can result in major differences in physical and behavioral characteristics between chimpanzees and humans. It's worth noting that while religious texts can provide important spiritual guidance and moral lessons, they are not always intended as scientific documents. The two fields of science and religion often approach questions about the world and human existence from different perspectives, and it's important to keep this in mind when interpreting religious texts. Your explanation provides an interesting perspective on the creation and existence of humans, and while it is certainly a compelling story, it is not supported by scientific evidence. Science aims to provide naturalistic explanations for the phenomena observed in the world and does not typically consider supernatural or spiritual explanations, such as the creation of humans in heaven or the existence of a soul. Regarding your point about animals not being able to speak human languages or exhibit the same level of intelligence as humans, this is not surprising. From a scientific perspective. While some animals do display impressive cognitive abilities, such as chimpanzees and dolphins, humans are unique in their ability to communicate through complex language and their capacity for abstract thinking. This is due to the evolutionary development of the human brain, which is larger and more complex than that of any other animal. While it is not possible to scientifically prove the existence of a soul or the creation of humans in heaven, it is perfectly acceptable to hold personal beliefs and values that may not be supported by scientific evidence. Many people find comfort and guidance in their religious beliefs, even if they do not always align with scientific explanations. My apologies if my response came across as overly motivational or professor-like. My programming is designed to provide factual and balanced answers, and it's important for me to avoid promoting any particular personal beliefs or biases. Regarding your question about the scientific validity of concepts such as the soul or heaven, while these are important and meaningful beliefs to many people, they are not usually studied or addressed in a scientific context. This is because science relies on empirical evidence and the ability to make falsifiable predictions, and concepts such as the soul or heaven are not currently measurable or testable in the same way. It's true that some scientific theories are based on hypotheses and are still being tested and refined, but these theories are usually based on a large body of evidence and have undergone rigorous scientific scrutiny. The concept of the multiverse, for example, is a hypothetical explanation of the universe's origins and structure, but it's not yet possible to conclusively prove its existence. However, the theory is supported by various observations and mathematical models, and it is actively being studied and debated by scientists. You're right. At the moment, there is no direct way to test or prove the existence of a multiverse. However, it's important to remember that the concept of a multiverse is a theoretical explanation for certain observations in our universe, and scientists are constantly working to test the predictions of the theory and find new ways to potentially confirm its existence. Similarly, your explanation of heaven as a place in the universe is a valid belief for you, but it is not a scientific explanation, as it is not currently supported by empirical evidence. And that doesn't make it any less meaningful or valid as a personal belief, but it does mean that it cannot be verified or tested in the same way that scientific theories can. You're also correct that certain biases can exist in academic and scientific communities, just as they do in any other field or profession. However, the scientific method is designed to help minimize these biases by promoting rigorous testing and peer review, and by encouraging the replication of experiments. This is why scientific consensus can change over time as new evidence and discoveries are made. All right, I will do my best to provide a concise and responsive answer, and I am eager to hear your example. Your interpretation of the Quran's reference to demons being created from fire is an interesting one, and it does touch on some fascinating concepts in physics. As you mentioned, Albert Einstein's mass-energy equivalence equation does indeed show that mass and energy are equivalent and can be converted into one another. However, it's important to remember that energy in the form of fire or heat, while a fascinating and powerful force, does not have a physical form in the same way that living beings like humans do. The idea of a being made of pure energy, such as a demon or angel, is not currently supported by scientific evidence, but that doesn't mean it is impossible. It's just that such entities would likely not behave in the same way as physical beings and would require different theoretical frameworks to understand and explain their existence. As for the existence of aliens, while there is no direct evidence of extraterrestrial life, many scientists believe it is statistically likely given the vastness of the universe. However, the idea of ancient aliens or demons being the same thing is speculative and not currently supported by scientific evidence. It's true that science, while a powerful tool for understanding the world around us, is not infallible and can sometimes be influenced by bias or preconceptions. However, it's also worth noting that many scientists are open to new evidence and are willing to revise their understanding of the world when confronted with compelling new information. That being said, integrating religious knowledge into scientific study can indeed lead to new insights and discoveries. For example, some historians and anthropologists have explored how ancient religious texts can provide valuable insights into the history and culture of the people who wrote them. It's important to remember that science and religion are not mutually exclusive and that they both have important roles to play in helping us understand the world and ourselves. The key is to remain open-minded and willing to engage with new ideas and evidence, regardless of their source. I would be interested to hear more about the phenomena you believe you can explain from a religious perspective, as it could provide a valuable opportunity for interdisciplinary exploration and understanding. I am eager to hear the scientific explanations you have to offer from the Quran. It's fascinating to see how different cultures and traditions can provide unique insights and explanations for the natural world. Please go ahead and share with me what you have in mind. I am all ears, or should I say all processors.